solution on an algorithm, on writing down, on coding the solution of a problem, and then evaluating and performing it as fast as possible. On the other hand, you are mainly focused on describing the problem and on, let me say, formalizing the problem. And then check the property query a system that is the solver of this problem that generates the solution state space in order to retrieve. So these are two totally different approaches that I also would like for you, would like that you get as a concept in general, and probably if you need, you can even try to further investigate by yourself, because this course is not specifically tailored on that. We also introduced the concept of compiler, of interpreter, then we saw why it's convenient, especially in the internet epoch, after the software even really important to have the combined solution, the plus or compiler plus interpreter, just because for portability and other issues, solving all the issues that are behind the just compiled or just interpreted language. Okay, now today we will start with the very first. Let me say, it's in general, it's usually a concept that you should already know, in the sense that when I say to you, in my opinion, the best place, the best timing for object-oriented programming is the second year. Just because we need concepts such as programming language, and typically we need that you know imperative programming at least. And on the other hand, usually such concepts such as the abstract data type, it's usually a concept framed into the course of data types and algorithm and data types that you are attending now, right, with Professor Fiumara. Usually this is a bit a basic, quite a little, how to say, a bit advanced concept that usually is done in the last part, but I need it. So we will try to introduce it, in particular from what we need. So I will try to stress in particular the two basic properties that are also the basic properties for object-oriented programming, that started with this concept of abstract data type and data abstraction in general. Sorry, I translated everything. I forgot the title. Anyway, why we need abstract data type? The traditional approach, I mean, as traditional, you know, it's the only one you should more or less know, that is the imperative programming, C programming, allow to define also complex data structure. Typically, what is named struct in C. So you are a struct in C is a sort of data structure that allows to bring together several different fields, several different attributes all together. Okay. Anyway, one, as discussed in this slide, one of the main, anyway, thinking about the data structure is one of the most important. The data structure in general in a program is one of the most important components. If we also think to the approach, the declarative approach, we say that describing the problem is already a solution. And this is also in line with this view. So preparing a good, working on a good data structure will allow you to solve, to faster, to better solve the problem. So probably in some cases it's also the only real problem as we said, mostly in declarative language, in declarative programming approaches. It's more or less the only problem. So it's a very important step. Just for several reasons, just because it's you are adopting a specific paradigm, or even in imperative language, choosing a data structure instead of another one could also improve the simplicity. For example, it could make the overall algorithm simpler, or it could also allow that faster. Okay, so it's a really important one. What is a data type? A data type usually it's a variable that characterizes usually a set of values and a collection of operations to this value. In general, we have that mainly we have these two main elements in order to define a type. A set of values that we can assign to our type, variable type, and a set of operations that we can assign. So typically, an integer has all the natural numbers. The set of operations is the sum, subtraction, multiplication, division, the traditional one. Okay? Then we can have also the number, string. Typically, string is another type by which that allows you, it's a sort of elaborated type in C that is a sort of array of chars. But it also defines some operation, append, charat, and so on. Okay? In general, this is really important. So, for now, what I would like you get from this first slide is the fact that a type is usually composed of a set of values and a set of operations, two main sets. So we can say that a type is composed of two main sets. A set of values that can be assumed by, that can be assigned by a variable of the type we are defining, and a set of operations that we can perform in the type. There are some problems in general. In traditional, usually, as you know, okay, we are defining now this concept composed of two parts. And as you can see, probably from your previous experience of programming, you know that these two parts are usually not so connected. So in general, when you define a data type, abstract, or whatever you want, usually you have to define the data type, and then separately you define the operation of them. You can even not define all of them. Okay? Usually the approach usually adopted in traditional, I mean in imperative programming language such as C, Fortran, and similar, the one we discussed last time, the approach is to define the set of values, more or less, that we can assign to a type, and separately, not together, we can define the operation, which kind of operation we want, but we usually define that. And this is probably a bit strange, because our definition see a data type composed of two parts that in traditional, approach in traditional data structure are separate. So now we abstract data type, we will try to make an abstraction, to recompose these two sets all together. We will see later how. Anyway, what is one of the problems that we can have with data structure? That if we assume, I don't know if you can see, it's very little one in the slide, we have a data type that is S, a data structure that is S, data S structure. And then A, B, C are three, let me say, methods, functions that we would like to assess the type. What's the problem? In order to assess S, A, B, C needs to know all the details of S. I need to know what are all the fields and what are probably the operation I can perform on that. Okay. If there are this is also a problem. Why it is a problem? It's a problem because if I will modify, for example, S, I have to modify A, B, and C. There is a propagation of any modification to S should be reflected on the A, B, C, on all the functions, methods, procedures, and so on that use S. Do you agree? Any modifications, if I change the number, the name of a field, of course, if I use the field, I have to modify all the modules that use this field and or use the structure of this. Furthermore, if there is a problem with S, another problem, so if there is a problem on S generated by A, probably, this problem is also, let me say, propagated to B and C. So these are not separated. So the access to the data structure is should be performed by knowing all the data structure, and any problem on S are usually propagated. Any problem generated, I don't know, by A on S are usually propagated to B, C, and so on. So the structure could be, I don't know, somehow invalidated and can be used. So what is stated here, an unnecessary propagation of information of S to the different modules. So probably I don't need to understand, to know the full data structure. Probably some part could be not useful for just using it. And probably it's better to keep this part, and we will see why to keep this part, how to say, let's use a term that is also technical, hidden to everyone. We will see why. The problem, as I said, you are that these three mostly. Error propagation, difficult to control and predict. What I said before. An error caused by a customer. A customer means also any modules that use modules, or better, any system, any function, any procedure that use S that generate a problem, an error, could result in another customer module or function, B or C, that instead has consistent data that assesses the data properly. So an error generated by one of the user, as I said, could also, A, for example, could also affect B and C. There is not separation. There is not a separation. This is check. This is difficult to maintain. Why? I said before, just because if I will change something on S, I have to change the code of A, B, and C. If I change the name of a field, I change the name of the structure, I will add a new field, and so on. I have to update A, B, and C, and this is a problem. This is and this is the problem for both these two drawbacks. Difficult in maintenance, because it's quite hard to understand. You need to know everything in access and maintain, and no reuse. Of course, this does not allow to generalize the type. It's usually the type is really specific for the problem we are targeting, and usually this does not allow to reuse. Here is what we say: the change on S would induce changes on all modules that use it, so very low generalization, reuse. The data structure reflects aspects related to the application and implementation, and therefore have not been designed to be reused. So it's typically focused on the problem we have in mind, not, it's quite hard to be generalized. So, okay, we saw all the issues and challenges. Now, let's try to solve these issues and challenges. These are issues and challenges, real issues and challenges of traditional data type. How we will try to solve it toward abstraction. Abstraction, of course, is a process by which we will try to generalize it in order to let him reuse, to be a bit better, a bit simpler to maintain, and to avoid error propagation and any other deep knowledge in aspects of the what are so the advantage, the target, the goal of abstraction. As I said before, is this process of rising up the level of abstraction, rising up, generalize a problem, in this case a data type, in order to cover, to be a bit more generic and abstract and solve the problem. For example, also including the other goals are the efficiency, simplicity of the program for assets in general, to be reusable, and generic, general application to the widest possible variety of situations. Abstraction from to work at a higher level of complexity. So also to extend the where we can apply it. Usually, this process of abstraction, it has been more or less behind the success of computer. We hear some noise from home. So if you don't have any question, please try to mute your mic, guys. Perfect, thank you. So the abstraction is a quite well used path, quite well used pattern in computer science. For example, starting from the bit and the binary coding, it's an abstraction from the analog, or the digital abstraction, from the analog, from the physical medium to a digital one, to numbers. So we are representing by numbers something, signal that is usually analogic. This is the digital process. It's a first abstraction, but also the computer model, abstract from the representation of the information. The model grouped together several, the computer model grouped together several blocks and so on, and provide you a set of instructions that can be executed on it, and it's programmed. You don't need to understand, to know all the paths, but you just need to understand to know the instruction set in order to program it. Also, programming language, as we said the last time, are an abstraction from the machine to any machine. So, to an abstract view of a machine that, for example, is the von Neumann machine or something like that, that can then run any type of algorithm. So, for example, using C instead, as we said last time, instead of assembly, allow us to focus on the algorithm. So we can write a generic program in a generic, let me say, high-level language, even C or Java, and so on, and then we can run it in any architecture. Depending on if we will write it on C, by C, okay, we will need any time to compile. But we don't need to change our code just because we are running it on, I don't know, an Intel-based or any other, or different type of processor, usually. The same for Java. Java even more is a further abstraction that allows also to abstract away also from the not only the hardware technology, so the architecture, but also from the software technology, the operating system, the middleware, and whatever you want. So with Java is the both Java and Python are quite well portable, just because you need only that the hosting node as a Java virtual machine, more or less, or a virtual machine, Python virtual machine, the Microsoft virtual machine, and so on, that run in the hosting node that has to execute the program. But in this case, you don't have to change the code, and your code is portable to anyone. And this is due to an abstraction that is performed by the virtual machine, the Java virtual machine or the language virtual machine. Abstract data type are also an abstraction following this, let me say, pattern that abstract away from algorithmic implementation. Is something on top of algorithms that can be used in any type of algorithm, and abstract to generalize the concept of data. We will see how. Just talking about benefits of abstraction, working at high level is what we said before, makes problems easier, usually. Algorithms can be analyzed indeed regardless the language with which they are then implemented. So usually you are higher level, as we said before, algorithmic, but we are even at higher level. Complex programs can be realized through abstract data structure regardless of their algorithmic implementation. So we have this abstraction process where different algorithms can use the same, for example, abstract data type. For example, typically, when talking about abstract data type, typically, and it's something that you will see also in algorithm and data structure, typically we are referring to concepts such as stack, such as queue, such as that probably you have not listed in some cases, but mostly queue and stack. That are usually concepts used then in, that are, if you want to use it then in different algorithms. It's just also trees if you want. So, or hash table are advanced concepts, advanced data structure that anyway are usually adopted in different algorithms. I have to solve my problems. Okay, I have to, I don't know, represent, implement an algorithm for managing, I don't know, a post office. I use the queue. Okay, I use the queue that is, we will see at the end of this system. Probably you don't yet know what is a queue, right? No, a queue is a data structure that usually where okay, in general, with abstract data type, usually we don't care about the implementation. You will see how it will be implemented. Of course, there are two ways. Usually, the static implementation through a vector, and a dynamic implementation through a linked list that you have not yet done. The list, no. So, okay, but the array I am. Okay, this could be either an array is a dynamic structure. Main philosophy of queue is first come, typically the one you have at post. It's that implement this policy. This means that all people or requests system are in a queue, in a line, if you want. It's the same when you are to the post office, to the restaurant, or to where there is us, and you need to ask. You go in line, and people that are before you have been you, depending that is the policy usually adopted in Q. Stack, on the other hand, are instead, these Q are usually named FIFO, fee and policy, first thing. There are also structures such as instead the stack that implement a little bit policy. It is last in, first out. What does it mean? Typically, as you put everything on the same let me say gate, let me say entrance, okay? So let us assume to have a car where there is only one door, okay? People entering the car, okay, will exit in the reverse order they enter. So enter the first, okay. A dish stack, dish pile, I don't know what to say, a dish stack, you take the dish, because otherwise, if you would like, you can, it's a disaster. You take the dish on the top and top a LIFO. Also, if you have a stack of retrace, usually you don't take the tray from this. Like this problem that asking from the people. No. I bring the opposite. The last number that yeah. This is just sample. It's so you can use that they are, but in general, real case stack implemented that is much an example that is important to manage the whole of nested functions. I already talked about the stack. Traditionally, in each of the process is the part of, let me say, if you are calling, the calling is and context is so the and only for calling program instead and use the memories memory of you call another subprogram. This subprogram is the stack. You will have when you have to step back from the because when a subprogram function complete the control program. Okay, so you need quite typical. Okay, we will at the because I will introduce this stack, but just quite quickly. Anyway, it becomes a sort of last in, first out policy, where you have this stack of calling programs in the order, in the reverse order they call. So at the bottom you have the first call, the first and the last. You have to go back. You have to return the call. The reverse, the control, let me say, function return the control functions, that it is the previous one. Control to quality, that return the control to the function, okay, so that's you go back to the stack. This is another real good example of everything. Let me now introduce what is an abstract data type. An abstract data type is, these are two different definitions. The first one is a data type that can only be accessed through a specific interface. Okay, this is quite partial, I don't know, I don't like too much. It's much better the second one. An abstract data type, or ADT, is a set of values and associated operations specified independently of a particular implementation. So it's absolutely independent of implementation. It is called client program. The client program is the program that uses abstract data type, and the implementation of the program that specifies the data type. Okay, anyway, in general, in abstract data type, we implement mainly two concepts that are two basic concepts also of object-oriented programming. We can say that, if you want, in general, we can say that abstract data type are the mother, the father, the parents of the relatives, the parents of objects, of classes. So the classes is strictly connected with the abstract data type. And the two basic properties are the two ones we are showing: encapsulation and information height. What is the idea? As I said before, the definition we gave of a data type is that it is composed usually of a set of values, if you remember, and a set of operations. Now, with abstract data type, we put order. We try to define an abstract data type as a compound, as a whole, as a unique element composed of two parts. The one is the set of values, the state usually, and it's named state, set of values, attributes, fields, whatever you want. The real data structure that probably you know, the meaning of data structure you know. Then the second part is instead a set of methods, of functions, of all the operations that operate, that are the all and only operation that operate, that change the state, that operate on these fields, attributes, okay? All the operations that can change the state of the attributes of data type are included as in the part that is named usually behavior of an abstract data type. So an abstract data type is composed of two main parts: the state, that is composed of all attributes, fields, and that describe the type, and the set of all operations that could could change on this on the set of on the state. This is termed also behavior, state and behavior, two parts. This is a process that we named encapsulation, a property that we named encapsulation, a very important property, where we group the two sets all together. So an abstract data type is a whole, is a unique entity that group together two parts, encapsulate two parts, state with behavior. This is a very important property. The second important property is instead slightly different and separate objects and conceptual operations, separate usually the organized, let me say, the abstract data type, also in this case in two parts, hiding the part that is not necessary to disclose to everyone. And in this case, we have a part that is hidden and a part that is public. So a public part and a private part. Usually the public part is named also external part or mainly interface. Important term, and these are the interface. And that the internal private part is the implementation. Private part or implementation. Okay, these are, okay, the benefits are the one we know, we will see that. Okay, in general, yes. Of what? Of yeah. I will now. It's just an introduction. Now we will talk a bit better, also with example about these two properties. The full class will be focused on these two concepts. So I will repeat, I think, at least 10 times. I will try even more probably. Okay. So the two main concepts behind abstract encapsulation. So bringing together the part related to the state, so the set of variables, of fields, of attributes that is the traditional data structure, with the functions, with the methods that allow to modify things. That is named the behavior, state plus behavior, encapsulated in a loop. This is first concept. Second concept is the information hiding some information in order, on one end, to avoid. There are three main benefits of them. The first one is to avoid that the user from the outside, the user that would like to use a data structure, needs to know all the structure, needs to know all the details, also details that are not important for it. Okay? A second benefit is that from the other side is that if I have a private part, I can preserve this private part. Okay? What if I am creating a data structure for a bank with the balance or something like that? I can preserve some part of the data. Okay? And I can regulate the assets if I want. I can preserve. Preserve does not mean that nobody will see. Could mean nobody will see, but could also mean that I can regulate the access to them. So, if, for example, I would like to preserve the field, the attributes balance, I can avoid to show it, or maybe I can add some methods that regulate the assets. For example, set get balance. Okay. When set balance, for example, I can say, okay, you can set the balance, but you can't set a balance below 0, for example. Or you can do a transaction that is greater than $100. Okay? Or whatever you want. The assets through a method allow to regulate these assets. It's a very good property for security, for safely enter into the structure. The second one and the third one is that the third advantage is that any modification to the hidden part, to the implementation, let's try to use technical term, interface and implementation, will not change the user. If I am a user of an object that is, I don't know, a cube or any data object, and I use this data object just calling the methods get, add, and so on, and I will not have access to the private part. The private part could be changed whatever you want, but I don't have to change all the user, all the modules, all the other, let me say, function that use this data structure. Okay? So these are the three main advantages, mostly of both of them, but mostly of information. Let's better the two. These are two very important concepts of object-oriented programming. It's a bit cold. Just 1 second, let me at least close the door. This is so hard, so okay, so what is encapsulation? Encapsulation, as we say,
Professor?
brings together these two parts. The two parts are, on one end, we say the state, composed of the traditional data structure with all the fields, all the variables, all the attributes composing our data, and on the first element, structure of state, and the function, the methods, the procedures that allows that usually allows to operate, to change the state, so to access, modify, and manage the attributes that is usually named behaviors. So also in this case, as we can see here, this is a nice picture just because it allows us, so it's not so nice because it looks like there's a pill. So anyway, we can say that encapsulation means that a data is a sort of capsule, a pill, composed of two main parts, variable and methods. So, for example, this is usually also a question that I ask to students during the exam. From the encapsulation perspective, an object, an abstract data type, then an object is absolutely the same property. About abstract, the same for all. Data type and is organized into two parts. This should be really clear. So if someone needs some further explanation, please ask. Any abstract data type or object is organized into two parts. The first part is composed of the state, and it's composed of variables and attributes, the fields. So, for example, person, the abstract data type person is composed of the fields of name, surname. We have in Italy a social security number, let me say something similar, it's named the codice fiscale, probably you get already it just to be enrolled, and something like that. Then this is the state, this is, here is named variable, but this is the state. The correct term is the state. Then there is another part that is the set of operation. So, for example, I can set the name, I can set the surname, I can, I don't know, create from all the information the social security number, that is codice fiscale, because it's possible, there is an algorithm by which it can be computed. So we can provide methods for that, and several other, I don't know, query and method. So, in general, from the encapsulation viewpoint, we have an object and abstract data type is composed by these two parts. Okay? Is it clear enough? I will continue. So, we have on one end the state, and on the other end the behavior that allows, provides all the methods, all the tools for changing the state of the abstract data type, encapsulated all together, grouped. So, a different perspective. When using an abstract data type, in order to modify it, we should remember that all the methods to modify it are encapsulated in the abstract data type. So I have to call only the methods included, defined in its behavior. Okay? So I define a variable D that is person, P that is person, then in order to modify it, I have to call a method P dot get codice fiscale. Okay? Sure, it's the behavior, it's included in this part of method, and I have to call from the same P dot, so the variable includes the methods. This is the difference. Even quite important, not even more important in some cases, but let me say it's important as well as encapsulation, is the information hiding property. Also in this case, from the information hiding is such a property by which we would like to keep, to hide part of the information of an encapsulated, of an abstract data type in different reasons. I would like, we say that, for example, probably we can see that in an abstract data type, this way we can have, let me say, two roles. The programmer, both of them are from programmer, but there is the programmer that is the creator and the programmer that can be considered the user. So we can say the creator and the user. You can be in the same time creator and user. Anyway, we should see the two different roles as a separated one. If you are a user, okay, from this, so the abstract data type allows you to propose, to introduce this double key. From the user viewpoint, when you are a programmer user, probably you don't need to know all the details hidden in the system. So probably you don't need to know of a person who is the codice fiscale or other information. So you just need the name, or the reverse, you just need the codice fiscale instead of others. So, or not all, this is, when using it, you don't need, probably you don't need to understand also if it is implemented by a static array or a linked list or a tree or something more. Probably these details are, no probably, surely these details are useless for you. You just need to use, for example, a queue, as we said before, to a queue request, to the queue request, to query how many requests are in the queue and something like that. But if it is implemented in an array, by a list, by a tree, or by something else, I think it's an information totally useless for you. Do you agree? It's absolutely useless. So, this useless information allows me to rise up the level. Because if I don't need to understand useless details, I can use different type of implementation that implement the same concept also in different way. So there should be the queue implemented in static, dynamic, and so on. I can use all of them using the same interface. This is done indeed with this concept, separating from the information hiding perspective an abstract data type or an object into two parts. That anyway, guys, please be careful. These two parts are different from the encapsulation one. So information hiding is a different property. Even if in some community they join it together, they have some relationship, but they are different. From an information hiding perspective, if you get the idea of information hiding, an object, an abstract data type is composed of two parts, different from the two parts of the encapsulation. One of the two parts is named the interface, is the public part, because we are focusing on hiding information hiding. So the two parts is one that is hidden and one that is public, not hidden. Okay? Is it clear? The hidden part is usually named implementation. The public part, the not hidden part, the public part is usually named interface. In order to use an abstract data type after you created or someone else created, it's not important, but in order to use an abstract data type, you just need to know the interface. You don't have to care about the implementation. It's not up to you. So, an important, also this is connected, an important enhancement introduced with information hiding is this double view, okay, of your role as programmer. You can be, on one end, the creator of the abstract data type, and on the other end, you can even be user. Okay? This is also important, the two roles, creator and user. As a user, you don't need to care about the implementation. Of course, as creator, you need to implement it. You need to care about the implementation, the overall system, because you are creating. Okay. If it is clear enough, we have these two parts, as we said, public or external, that is interface, or private or internal, and it is implementation. Okay, this way we have some examples. So as you see in this slide, these are the two parts. As you can see, this is a nice view, even if in general, okay, we can say that interface and implementation does not depend on, are, we say, orthogonal to the encapsulation one. Encapsulation brings together, we say the state, data, or variables, or fields, attributes. On one end, you have this state, the attributes, the fields, or whatever you want, and methods. While the information hiding usually split into two parts that are the public part and the hidden part. In this case, probably these figures are not so good, because usually you can have everything. You can have either a field, either an attribute, and usually the methods as interface, while the implementation, that is the hidden part, so you have this outlet is the interface, that if you want is a shield for the part before. But in this case, there is, if you want, an error in the sense that in the interface we can even have also data, we can even have also attributes, okay? So it's, as I said, you're orthogonal to encapsulation. Please be aware of that. If there is a problem, ask me, because these are simple concepts, but then we have to apply, and we need to be always, this needs to be always clear in your mind when applying it. So I will stress this today and later plenty of times. Sorry to be repetitive, but it's really, really important. So in general, what I said to you, the interface can be composed of both attributes belonging to the encapsulation state part, and usually methods that belongs to the behavior part of encapsulation. So, as I said, you orthogonal. Something similar here. You don't have only methods as an interface. You can have only data, only attributes, as well as some of only attributes, as well as the implementation is not. There is no rules that say that you have just the data in the implementation. You can even have methods. At least this is represented here. You have public function usually as an interface. There could be also some public data as interfaces, some public attributes, plus public function, public methods, and instead some behavior could be also hidden. So also, this is not only data. Data plus private methods. This is not only method. It's methods plus public data. Okay. Is it clear, guys? Okay. And then you have usually one of the main goals, of course, is to protect data. So that's why usually the main usage, the main implementation of information hiding is this way, where you have, or maybe this way, where you have the function and then all the data that are usually kept private. But in general, the rules does not specify that anything about that you can have also data as data or mostly attributes as interface, in the interface. Something similar, yes, about this concept is shown here. And it's nice, this is in particular a very good example about a vehicle. If you want, the abstraction is the, how to say, the success solution by which that is implemented, for example, in vehicles, and that allows us to drive more or less any vehicles, let me say any cars. So, in order to drive a car, you don't need, all of us, don't need to understand if the engine is fueled by, I don't know, diesel, is electric, is gas, also, or have, I don't know, is composed of different parts, is four-wheel drive, I don't know. We don't need to know the details on how to do it. We need just to know the interface, the steering wheel, the swift gear, and the pedals for accelerating, and so on. Okay, there should be slightly different version, the automatic one with the automatic gear, or but usually all of us, I don't know, I would like to rent a car. I don't need to study before renting a car which type of engine, how many watt, and so on. How it is the engine or the other characteristics, right? We don't need to do something like that. We just need, we already know the interface, steering wheel, pedals, the swift gear. Oh, that's exactly the concept of that we are trying to understand with information hiding. We have an interface and we have an implementation that change car by car, but allows us, just knowing the interface, to drive all the cars, more or less, that have the same system, but more or less all of them, at least one. Unless, of course, we are not able to drive truck, but it's quite similar, or to drive a bus. But it's not so difficult anyway. The interface is always the same, more or less. Okay? This is a very nice example. Here we have another example, always splitting between interface and implementation. This is a very important advantage. So now let me show one more time what are the advantages of implementing these mechanisms. The advantage, as we said, we have to consider the two viewpoints. First of all, let us consider the viewpoint of constructor, of how to say, of programmer creator of an abstract data type. If I am a programmer creator, I can implement some mechanism to avoid, to hide some information to the user. We will see later. But my goal in hiding is hiding some information that could be quite critical, for example, that I would like to not disclose. I say to you, I am creating a system for a bank. I am the creator of, I don't know, the bank account abstract data type. For sure, the customer asks me, okay, please don't disclose this for, I don't know, a new credit card. Please don't disclose or provide me a set of rules that should be applied. If you have the balance below 0, you can't make any purchase. It's reasonable. So if you, I don't know, you can make purchase greater than, I don't know, as we said before, $100. We can make a list of rules. So as creators, we can implement some mechanism for controlling the access to this balance, for example, and we, instead of making it private, public, we will keep it private, we will, and provide this shield with a specific method, for example, that could be get two methods, usually the getter and setter, we say, we will see later, that allows to enter, access, read, and write on it. The write method, set, the set method, usually set balance, will be a method that says if, for example, balance is greater than 0, if sum is, before this, is sum, the amount that you would like to spend is greater than the balance, and so on. Okay, I can specify if some amount is lower than 100, I can put all this control. If I don't put all such control, okay, anyone, and I leave the balance as a public composing the interface, anyone could change it without the control. So, from the creator perspective, the main goal, I have a powerful tool with this information hiding to protect the access, to protect my structure, okay, and to regulate the access to them if I would like someone else enter. Otherwise, I can avoid anyone to enter and modify the system, and I will modify it with the internal mechanism. You get the point. So, usually the creator of an object or of an abstract data type, the information item to this creator allows to provide mechanism for protecting, for hidden, for for hidden part of the code. Okay, for usually security purpose. Let me say in general. Now let's switch to the other side. From the user viewpoint, from a programmer user viewpoint, when using a system, we have this advantage. So in order to use an app, the first important advantage is that I don't need to know the implementation, I just need the interface. I can drive any car just because I know how to move the steering wheel, I know how to act on the Swift, on the gear Swift, and I know how to act to the pedals. That's exactly what we say. I can use any data just because any Q data, any tree data type or something like that, just because I know that the mechanism for using it are, the interface for using it are exactly these 3-4 methods, and stop, okay? Another advantage is that if, that is from both sides in general, is that if I would like to change my implementation, if I would like to change the engine of my car, if I would like to transform my car from, I don't know, a car to the one with, I don't know, NOx or something like that, okay, it's a bit more dangerous, but the pedals, the interface is always the same. Now you have to better dose how to push on the accelerator if you change everything. But of course, any modification, it's not visible to the implementation, as we said, to the engine. I can change the seat, I can change whatever you want. Any modification to my car, to my the abstract data type, does not reflect to the people that use the system. I don't have to change the implementation of the user, okay? You can see this is a very big advantage toward reuse, because these allow to use and reuse whatever you want. Okay, I can use the same plenty of time wherever I want. I implemented it, I would like to change, I will add a new features, I implement a better version of my cube from static implementation with an array to a linked list, to a double linked list, okay, perfect, do whatever you want. The interface is the same, I will continue using it in exactly the same way, okay? Exactly, I don't have, as a user, I don't have to change my code. And this is great. This is the third advantage of information. Yes, this is exactly shown here. So abstract data type is a sort of concept of secretary. So as you can see, this is D is the abstract data type that of course encapsulate, and S, if you want, is the implementation. Okay, any change here in S does not, if I leave the abstract data type and its interface the same, does not reflect, does not change, is not visible outside. Okay, I don't need to change anything. So did you see the real power, the reuse concept of that? Okay, to assess procedure, so that's exactly what I mentioned. This is the second property assigned, safety. This is from the creator perspective, from who is creating. So in order to assess the balance, for example, here is shown another property that could be, so two or more users that assess in the same time the balance. And this could be a problem, because if both of them spend, I don't know, $1,000, and both are authorized, then you will get a balance that is below 1,000. It's not authorized by the provider. You get the problem. Here, instead, if you synchronize the access to this, instead of having a public balance, you have a private balance. If you synchronize the access to them, and two user program would like to spend $1,000 in the same time, they have to go through the put balance, for example, and since put balance can synchronize the access to balance, okay, and then spend one by one. After the first expenses of $1,000, the second one will be not authorized, because the balance will be updated, will be zero, will be lower than the other $1,000, and the second one will not. So in this case, you will get the real big important part is that you will get a proper use of this. You can implement a safe access to the, and you can check the access to the balance, because the problem, of course, can be many. Okay, and this is the second aspect we said, and the third aspect is that it's shown here with the car in terms of use. So easiest user, so general user, we can use any car with the same approach, with the same interface. Second benefit, let me say this one, we can modify our car. We can modify our car, the implementation of our car inside. We can change all aspects, wheels, whatever you want. And anyway, the user will use the same, and the other people that are using the same car, the same auto, can use the car in the same way as before. We still have the wearing steel and so on. And then the third one is from, instead, the creator perspective. We can keep hiding the information, we can keep save the information, and we can implement proper access. We can regulate the access to our data, or to our, if you want, also private part that can be also composed of methods. Some examples. Sorry guys, both here and Tom, I didn't hear from you since a while now. If you have any question, guys, please tell me. You are something like 16 from home, and probably there is something that is not clear. So please interrupt me whenever you want. If not, I will go on. For you here, it's clear enough, right? This is an example about that. That point. Sorry, I can't read it from there. So in order, an abstract data type can represent a Cartesian, a two-dimensional point, and providing mechanism for, I don't know, setting the coordinates and something like that, such as assignment, comparison, and something. This is done without revealing the internal implementation details. So we don't need to disclose the information detail. The interface must mask the implementation. So, for example, we have as interface just assignment, comparison, and something. But as internal implementation is done here, just to make an example of information hiding, we can have different type of implementation. We can implement some of these points by Cartesian coordinates, some other by polar coordinates, R and theta. Okay? This could be two different systems. We will not need to understand, to know if it is implemented by a Cartesian implementation, because the system does not need to provide, to set these coordinates, but gives just assignment, comparison, and something. Does not ask to deal with these parts. Or maybe it implements probably some mechanism hidden to, if you specify your system in one of the two systems, to map to the other one. You want to be able to change the internal representation without the client program having to be modified. This is another important. So we can have both Cartesian and coordinates and polar coordinates, so different implementation, but the same interface. And we can even, the creator can even be free to choose which one, and even to change later the implementation, the implementation of he/she who wants to use. Another example is the sequence, that is in general an abstract data type that allows to manage an ordered collection of items, generic items, regardless of a particular implementation of the items. So we are not, so it usually provides the list of items ordered somehow, and it implements also the current item. For example, its interface could be this one, composed of sides that returns the number of objects in the sequence, before insert an object before the current position, add after the current position, remove current, return current, start, make the first object the current item, so move the pointer to the first, advances, increment the current position, so it could be increment, current read, true if there is an object at the current position, find looks for position of an object in the sequence. So this is exactly the interface. Let's try to start reasoning in terms of abstract data type and then object exploiting this property. The property of abstract data type can describe collections or collection of elements that could be also abstract data type in their turn. This collection can be dynamic, i.e. the number of elements can vary. Of course, the elements generally have a structure consisting of a key and possibly other data. So usually these elements, okay, you know, this is the traditional, I assume you more or less know what is a data structure. Usually when creating a data structure, you need some sort of key data that univocally identify each data. So usually a key on a person, as we said before, would be the social security number, this codice fiscale, or in a car would be the number of the frame, I don't know how to say, the number or the plate. something like that. The key typically has a value that is in a totally ordered set and identify univocally the operation of abstract data type are usually, sorry, just 1 second, I have to change the title. The next one, it is still in Italian. Okay. The typical operation of an abstract data type can be grouped into four main classes. The initialization one, to add an element, usually to remove an element, or to access the elements of the abstract data type. Adding, inserting a new item, or the union of two collections, so it's just inserting one new element, or grouping together, merge two collections. The cancellation, deleting, it's removing a specific item. The access could be, for example, to search an item with a specific key, to provide, yes, all the access like the average value, or successor and predecessor, selecting the smallest key element, sorting or traversing the collection ordered by key. So we can have different type of accesses. As a first category abstract data type, we have the abstract data type that is usually is implemented define a type, and therefore it can be usually instantiated by proper mechanism and assigned to variables. So a first category data type, first class data type, it is usually first category data type, that is also a class, we will see later. Data type of which multiple instances can exist, so that can be instantiated many times, in general, so define a type, and to which we can assign variables. We can define variables of the type, and we can assign the instances to the variables. The concept variable and instances you should get from, so more or less, and instances are more or less the same. The pointer more or less change a bit everything. In object-oriented programming, start to be differentiated. Usually, a variable is something that is usually used on similar, while the instance is instead the let me say the allocation of an object. So an instance is the allocation in memory of an object. The variable is a location that usually, for example, is the pointer to this object, or could have also point to somewhere else. So the concept of variable and instance in object-oriented programming are quite different. Even before, but the difference now it's much more. It's higher. Let me say. There is a greater difference between the two concepts of variable and the concept of instance. Instances is some data on the program memory. Variable is some sort of, yes, variable, an unknown that can change its state, and is usually a pointer to some object in the memory. We will repeat plenty of time, but start thinking that we will give more or less a new, we will do a special type of, let me say, usage of variables in object-oriented programming, and keep in mind that variable is different from object, okay, from the term object from attributes and so on. And an attribute is not a variable, is a field of an abstract data type or of an object of the composing its state. It's not the only part, as we said before, because for encapsulation we have the state and the behavior, so also the methods are part of the of the abstract data type or class. Benefits, we already commented on it, so we will try to wrap up this concept. The advantage is that we can have controllable and predictable error programming, error propagation, and security. That's exactly what I said to you when talking about the creator perspective, to save let me say, the access to the data, so we can have some protection and predictable error programming, just error propagation, so we can limit the propagation, just making some path hidden, okay, by information ID. We say creator side, from the creator perspective. Easy to maintain, modification, containment to the implementation. Also in this case, is easy to maintain in the sense that of course, in order to maintain it, we have to just act to its implementation. We need to change the implementation and not the rest. Last but not least is easy to use and reuse. We say we just, in order to use it, we just need to know the interface as well, a car or with whatever you want, and does not need the implementation. We don't need to study the manual of the car or to study how the engine, I don't know, burn the fuel or which type of. We don't need to know all the details of the car, but just need to know its interface. And this allows then once we will we will know how to drive, we can drive more or less any car, any vehicle, more or less, not all, of course. And this is easy to use, and in particular, this is a very important aspect also to reuse, because then you can even, knowing that you can even reuse the same concept in other products, that it's something that we can also target. As I said to you before, one of the benefits and of the paradigm shift that we have with object-oriented programming is related to the fact that we are not just focusing on a simple algorithm, but we are also targeting something that is named programming at large, a software architecture. And in general, software architecture, and in general, if you want also, we are starting implementing some basic concept of software engineering, where reuse is one of the most, the main principle, just to optimize everything. Reuse means saving time, and therefore, for who make business on software, saving money. Okay? You get the point. So we are now switching from the simple programmer viewpoint to a simple programmer of just an algorithm, to a programmer of in a wider scope, where we are targeting software system, software architecture, not software architecture, so not anymore just the simple algorithm. Okay, that's why reuse is something that we are targeting. It is an important perspective. Okay, features of the ADT. ADT encapsulate both the data structure. We saw these are quite repetitive within a module. An abstract data hides all the tiles that are not, so there is the encapsulation. Information ID, the abstract data, therefore, allows to realize an abstraction on data and control. On one end, yes, on data, just because it encapsulates everything and put everything all together. From control, just because we will control it, the abstraction on control, just by an interface. So an interface is an abstraction of the control, just because we need to know just a few elements, while other operation, more complex operation implementation, is hidden. Typically, an abstract data is made through an appropriate modules, an appropriate part of it. A module is a set of resources, of some which are visible outside interface with others, while others are only local, the implementation. We have this information. However, a module is the result of an abstraction operation, of course. This is already done. Modules as an abstraction of controlled data. Both the data and the control can be probably encapsulated by modules. I don't know why box. By modules. Encapsulation alone, however, is not enough to characterize a module as an abstract data type. Why? We know, because we need to further abstract control. And this abstraction in terms of control is implemented by mostly information. This system, organizing the system from this perspective, hiding some part in order to make the use of also the abstract data type simpler from the outside. So just requiring to know a given interface. Okay, this is another example of information hiding where we have a complex number that is A plus J B, and where the interface is composed of these elements that are anyways sum, subtraction, multiplication, division, initialize, real part, imagine part, module, and argument. Okay, the use of an abstract data declaring the data type. Okay, how to use the data type? I said to you before, it's the abstract data type due to encapsulation comes as a rule. So after assignment, initialization, and so on, it should use only these methods. So in order to only and only one, only these methods. So, for example, for this one, the only way of changing its status are through these 9 elements. We can't use something from outside because everything is encapsulated, as we said before. We have the behavior and the state of the behavior. And the behavior, the set of methods are the only methods that can change the states. No all methods can change the state of an abstract data type. This is related to the fact of encapsulation. Manipulated data type instances using the primitive operation encapsulated in it. The abstract data type operation, the behavior, are the only possible operation that allows to act. Okay, in terms of representation, the last few slides, to represent a data type is necessary to provide description that could come up within 3 main models: the syntactic, semantic, and pragmatic. Usually, a syntactic representation provides usually and mainly the interface, the set of elements from the interface. So it's not enough to describe in total an abstract data type. So the syntactic view is clearly incomplete because it specifies only the interface of the data. So in this case, this could be considered as an abstract view where we know only the interface. Then we can use either the semantic or the pragmatic view. Okay, the 3 of us are redundant, so we don't need to have to know all of them. We can combine syntax and semantic, or syntax and pragmatics, more or less view. For example, combining the syntactic and semantic views provide a complete description of the data regardless any other implementation methods. The pragmatic view is redundant in this case. It does use information for the values for the data behavior, so it does not add anything else apart to the information we have from the syntax and the semantic one. Okay, the sample at the end, the summary at the end. This is a counter, for example, another example that introduce in a counter 4 main or 5. Here we have 5. I don't know if you can see 5 main methods for as the interface. We have new counter, increment, decrement, value, and is. According, based on this, we can increase, decrease, increment the current value, null counter control. So we can set to 0. No, we can check if it is 0, or we can new counter, define a new counter as the fifth one. By design, we said that the counter cannot take negative, so it's it's natural. As you can see, this is if you want finite state machine that describe more or less the syntax specification. You have a new counter that creates the counter, then a method that increment or decrement the counter, defined on the counter, and with values on the counter. So increment and decrement the counter. Then we have a value that is a natural one that probably return the value query, and is 0 that return a boolean checking if the counter is 0 or not. This is just the, as we said before, this is just the interface we defined before. This is described just the interface specification with the parameters in input, output, and so on. That is also expressed here with state machine. Specific syntax like that. New counter is a function that returns a counter. Increment is a function defined on a counter that returns a counter. Increment the counter. Decrement this defined on the counter, and is 0 is defined in a counter. As you can see, this is the input, and to define the on counter, and this lacks of semantics. For example, in this way, for all counters C in the class, in the abstract data type counter from an high level viewpoint can be described this way. We can have the method that is decrement of new counter means that it's equal to new counter, define some rule. Decrement of increment C, it's the same, so return C. Value of new counter, if we start and create a new counter, return 0 because it's the initialization. Value of increment on C, define 1 plus value on C. Is 0, it is defining all the operation with. Is 0 new counter equal to true, is 0 increment on C is equal to false, of course. And these are some rules, probably not all of them, because probably we miss something, but they define somehow, as you can see here, the behavior of the abstract data type. The semantic part, it's a bit more related, if you want, to the implementation, while the syntax part is more related to the interface. So the two parts, more or less, as we say here, are complementary, and this describes mostly the interface, and this the implementation. Okay, now at the end of this class, I would like to talk to you about something that you should already know, that is the concept we have introduced at the beginning of this class, the concept of lists that are typical data structure, typical abstract data type, by which, of course, we can anyway, even if you don't know, probably you will know, but so probably the concept of list should be known. You should have done, I don't know, the pointers, for example. pointers, and the linked list is the first example of the list. It is a dynamic structure, usually, by where you have, it's composed of, it's a data structure, static data structure in the C, let me say, context that is composed of a data plus a link, let me say, plus a pointer to the next one. That's why linked list is the list of linked. You have linked with the next data and linked till the end. It is a null pointer, and this is the usually you use it to implement dynamic structure that are, let me say, if you want, in several cases, a good alternatives to array, even if they are a bit more complex. Is there any question from home? Okay. I can hear you very bad, so if you have a question, please probably better you type. Muhammad, do you have any question? Probably it was not a question, but just okay. This is a linked list. Anyway, what is important from my perspective is to show it as an abstract data type. So a linked list from an abstract data type is composed as any other data type of, in terms of encapsulation, there is the set of the data structure, as you know, as a list. There should be usually an attribute with data, and the next as the pointer to the next one. So the data structure is composed usually by these two main elements, and then mainly the state, while the behavior is composed of the methods. Some methods usually is full, get, insert, remove, remove at, replace, cite, is empty, is full. These are methods from the abstract data type that, of course, can even be considered as part of the usually interface, while the implementation is something that is mostly related, it's hidden mostly. So in this case, the part, if I will implement it, usually implement it in this way, but I can even implement list. For example, in this case, we have double linked list. This is a linked list. This is a double linked list with two pointer to the pre or of 3. It depends on. It could be considered still an element. In this case, as you can see, it's a sort of tree. It is a non-linear list, or anyway, we can have different type of implementation for that. And anyway, any type of implementation is something that is hidden, and we expose only this set of methods as interfaces, get, insert, and so on. Something similar to the queue. So from an abstract data type viewpoint, a queue is the structure that, as I said before, it's the one that implements the line, the queue in, I don't know, in the highway or in a post office and so on, and allow to serve first come, first served, or first in, first out. Also in this case, this can be implemented in several ways. So the state is the state is composed of this part, while the methods usually are these methods one that also are usually all exposed as interfaces. So the interfaces are of a queue is usually composed of a queue, the queue, pip that return the current element on top of the without the queue, and queue introduce a new element, create a new element and introduce it in the queue. The queue extract an element from the queue and remove it from the queue. Pip just get some sort of information from the first element of the queue without extracting it. So return, I don't know, what is the next in line? I am the next in line, but you have not been extracted by the queue. Site, return the site, is empty, is full to Boolean function for checking if it is empty and full. A queue, of course, can be then implemented in several ways. We said as linked list, simple, double, and so on, as well as by array. Why not? There are static implementation, even if are not so efficient, because of course a static queue is a queue with given is using a static array will be limited to the number of the elements of the array. It's not the best solution, but it can be even implemented this way. But independently, regardless of which type of implementation we use, the interface is the same. That's why this concept of information hiding it's really important, just because we can use any queue in the same time. But it is implemented by a static or a dynamic or a different dynamic system or a different dynamic implementation. Something similar for the stack. The stack is also, as we say, the last in, first out. As we discussed before, we have it in several examples, the dish stack or the people entering, I don't know, the stack of I don't know, journal or magazine. We have Tom, so where we need to put and let me say keep everything from the top, more or less, from the same side. So where we have usually one just entrance. This, similar to the queue, can have, of course, can be implemented in several ways. Can be implemented either in by static array or dynamic list. All of them can be anyway. In all such cases, a stack usually has an interface like this, composed of the methods such as push, where I put an element on the system, pop, when I extract the element of the system, removing from the stack, pip, as before, give the first element without extracting it from the top top of the stack. Estimate, I don't know exactly, is full, and is estimate is something probably related to understand how many elements are in the queue, while is empty and is full are the two methods related to check if the stack is full or is empty. Yes, please. No, this is generic. This is generic. It's an abstract prototype. As I said you before, this is even generic on top of algorithms. So you can use in any algorithm, stack, a queue, and so on, depending on. Yes, it's empty. This is the interfaces. Yes, this is the interface that are usually implemented in any language. So there are, for example, libraries that implement stack, queue, and so on, and usually have the same different implementation. Usually even have. Yeah. The idea is just to show you that in general a stack or a queue and so on organized this way can be reused plenty of time, and the benefits are just you can on one end you can save your time and of course your effort, the second is that usually these mechanisms are the one provided by also by third parties, are usually quite well checked, used and reused plenty of time. So they are usually bug-free, or at least they are really very well checked, just because they have been used by a wider population in several cases. So this is another, how to say, benefit of reuse. So see me just starting thinking as a programmer, professional programmer, not a programmer for just a simple problem. As professional programmer, reuse start becoming something. Yeah, it's this is an example in general of abstract data type and reuse. The car scene is an example. Yeah, the same is the same interface, and the difference between interface and implementation. So the information hiding concept together coupled with the encapsulation behind abstract data type. Okay, guys. That's it for today. I need to run to my next class, and therefore we can close here the class. Do you have any other classes here? Yes. So I can leave you the key.